available. So the final presentation today is from myself, and I am currently researching at PhD level in DIT into the social dynamics of collaboration driven by industry adoption of these collaborative BIM technologies. One of the areas that has come to light from my reading is the rising tide of blockchain adoption. So I want to get a sense of an understanding of the area of blockchain. Could I ask who has heard of Bitcoin? Nearly everybody here, great. And who has heard of blockchain? Okay, about half. That's grand. Now I want to put this in some context first. So there's evidence all around us that we are witnessing a digital transformation in the design and construction industry. And the technologies of this transformation are disruptive to existing procurement process. This is a good thing. Because it is from this disruption that new innovation can spring forth, and we are working towards a multidisciplinary collaborative procurement process that has potential to be leaner, efficient and more cost-effective process. Up until now, there have been well-researched reports calling for a more collaborative process in the building procurement witness, as has been mentioned before, the Latham and Egan reports in the 1990s from the UK. And while these have been accepted by the industry as correct and viable, the recommendations have been difficult to implement. This is because of a number of factors, one of which, and is essential, is the factor of trust. Trust has been mentioned here before. The culture change that we hear in the BIM community, almost as a mantra of BIM, is actually a call for more trust amongst the stakeholders in the design, construction and building operations industry. And this includes our clients, designers, contractors and our facilities managers. In traditional building procurement, we have developed systems which are heavily reliant on contracts, which often pit the client against the contractor in a lowest tender scheme, administered by third party, and often the third party has skin in the game and walks a fine line between acting on behalf of the client and the interest of the contractor. There's nothing particularly new here. However, what is new is the nature of our building information is changing because we are moving from representation to simulation. So this move from 2D plan sections and elevations to information that is drawn from the building model that was very well explained by Ralph. The essence of disruption, of a digital disruption, ongoing in the digital transformation of the design and construction industry. And the nature of this disruption is that it knows no boundaries. It disrespects the existing hierarchies and it regularly slays sacred cows. And we just have to witness the music industry, the publishing industry, the travel industry, the financial services industry, and on and on and on. The design, construction, building operation industry is perhaps the last surviving major industry that has not felt the full force of this digital transformation. But this is no longer the case, and at the heart of this transformation is BIM, and now, I believe, blockchain. While BIM is the current best solution for the creation and management of building data, blockchain is a possible solution to the problem of trust. This is what makes blockchain so interesting. In order to establish trust, we need to provide evidence of trust. And blockchain's big innovation is trust, not money. So move Bitcoin aside and start to look at the underlying technology that drives Bitcoin, and that is blockchain. It has been referred to as a revolutionary technology by IBM, a once-in-a-generation opportunity by PricewaterhouseCoopers, and perhaps the most descriptive title came from The Economist when they dubbed blockchain the trust machine. So what BIM technologies allow us to do is to construct this building virtually to a very high level of detail. The building models are shared amongst the designers, contractors, clients, and can provide an important step in terms of evidence of trust. However, sharing a model is only part of that solution. What blockchain can do is allow people who may not have established trust with each other to transact value with 100% confidence. Blockchain provides security, accountability and transparency on the transaction that is in essence immutable evidence of trust. So how did blockchain arrive onto the scene? Well, most of you here are familiar with Bitcoin. Bitcoin is a cryptocurrency. And Bitcoin has a reputation, not always a good one. But Bitcoin was born in 2008 when 3 individuals filed a patent application for a new sophisticated encryption technique based on heavy mathematics. 3 also registered the name bitcoin.org. And then an anonymous white paper was put into circulation under the name of Satoshi Nakamoto, and it revealed a purely peer-to-peer version of electronic cash to the world. In this vision, they managed to solve the problem of money being copied securely, which provided the vital foundation for Bitcoin, and that foundation was known as the blockchain. What is of interest to us is not Bitcoin, but it is the theory and the technology behind it, and this is distributed ledger theory, more commonly known as blockchain. A distributed ledger is essentially an asset database that can be shared across a network of multiple sites, geographies or institutions. All participants within the network can have their own identical copy of the ledger, decentralized. Without the consensus or need for a central authority or middleman. That's a revolutionary thought there, right straight off. Banks and financial houses have tried very hard to suppress cryptocurrency, but they failed. And they were left with no option, as in, if you can't beat them, well, you better join them. So there are currently 90 plus banks pouring huge amounts of time, effort and money into researching and developing methodologies for the blockchain use. Now, I don't have enough time here to go through the mechanics in terms of how blockchain works, but I'm going to play you a short video clip in a minute which will explain blockchain. But it's more important and significant to note that blockchain is here. It cannot be uninvented, and it is going to play a major role in the disruption of current centralized systems. I have to work a little bit of... I'm going to play a little clip here, about a minute of this clip, which gives you a visual idea of BIM, if you've not seen a BIM before. Example of this data that is contained within these building elements. That information that Ralph was talking about is contained within a whole set of parameters which refer to this window door that's there, and all of this information that we can now use, generate, including the manufacturer's installation instructions right down to the cost of the actual unit itself. How does that relate back into the blockchain? Let's have a look at this and see.
Modern technology allows people to communicate directly. Voice and video calls, emails, pictures and instant messages travel directly from A to B, maintaining trust between individuals no matter how far apart they are. When it comes to money, people have to trust a third party to be able to complete a transaction. Blockchain technology is challenging the status quo in a radical way. By using math and cryptography, blockchain provides an open, decentralized database of any transaction involving value, money, goods, property, work, or even votes, creating a record whose authenticity can be verified by the entire community. The future global economy will move towards one of distributed property and trust, where anyone with access to the internet can get involved in blockchain-based transactions, and third-party trust organizations may no longer be necessary. The uses of blockchain technology are endless. Some expect that in less than 10 years it will be used to collect taxes. It will make it easier for immigrants to send money back to countries where access to financial institutions is limited. Financial fraud will be significantly reduced, as every transaction will be recorded on a public and distributed ledger, which will be accessible by anyone who has an internet connection. Think of it as wills and contracts that execute themselves, or dated proof of existence for ideas, much like a patent. Blockchain will become a global, decentralized source of trust, but not everyone is ready to embrace it. A huge proportion of trust services, from banking to notaries, will face challenges on price, volume, and in some cases, their very survival. Public authorities could find it more and more difficult to enforce traditional financial regulations due to the new possibilities offered by the Bitcoin network to bypass traditional financial intermediaries. Unimagined new networks will evolve to meet society's needs more cheaply and potentially more securely. Will governments, financial and legal institutions embrace blockchain? What will happen to the ones who don't?
So as I started to read into this, this started to ring bells with me. A BIM model is basically a database. That's what it is. It's a series of zeros and ones. And that information that we talked about, again, is digital information. And the connection of the two started to ring bells with me, and I started to investigate that. It wasn't a full solution here, but something else popped up which added in terms of perhaps providing that solution that I'm talking about. So while blockchain has immediate economies in terms where value is virtual, we in the design and construction and building operation industry have a different set of problems. So financially, yes, they can work with that idea of a cryptocurrency. But actually we work in a world where our virtual value requires to be turned into a physical value. Okay, so how are we going to do that? The latest innovation of blockchain technology includes something called smart contracts. And smart contracts, in the context of blockchains and cryptocurrencies, are pre-written logic, computer code, that's what they are. Stored and replicated on a distributed storage platform, i.e. the blockchain, executed and run by a network of computers, usually the same ones running the blockchain, and can result in ledger updates. Now, to put that into reality, David was talking about the paving contractor over in the UK. So turning the virtual into the reality is a trusted third party going out, surveying that the work has been done on a tablet or on a phone, going out, filling out a small form and sending that form. That form, once it hits the blockchain, instigates a smart contract which instigates payment instantly. So there's no hanging around and waiting for it. If it's done and it's verified, then it's paid for. That becomes very interesting. So a smart contract is some code which automates that if this happens, then do that part of traditional contracts. Computer code behaves in an expected way. It doesn't have the linguistic nuances of human language. Code is better as there is less potential points of contention. The code is replicated on many computers, distributed, decentralized on a blockchain, run by those computers who come to an agreement that on the results of the code execution. And there's an example of, you can't see it too well, but there's an example of a smart code written on a distributed, decentralized organization called Ethereum. And Ethereum is a specialist decentralized platform for applications that run exactly as programmed without the chance of fraud, censorship, or third-party interference, and Ether are making a promise that smart contracts on the public ledger will be as easy to build as dragging and dropping puzzle pieces into a web page. That's really exciting. A smart contract for construction. A smart contract, what potential does this have for us in design, construction, building, operation industry? Well, the answer is lots. An adjudicated smart contract is a smart contract whose execution is contingent on the physical observation or judgment by a reliable witness. This can also be verified and validated by the construction as-built digital modelling, with model checking against a previously digitally signatured and locked down version of the pre-construction building model. So what that is that a planning model or a tender model is submitted to the blockchain and is locked down and timestamped as the version. This is what you are paying for. As the building is being constructed, we have a system that we know that is a quite inefficient and expensive system and puts off a lot of responsibility in terms of our professions. But if we have a system whereby we can go to site and verify that the work is being carried out, and again, the verification sets off a smart contract and that person is paid on the basis of the verification of the work being done. Now, this can be done physically by somebody, but also can be done now by technologies as well. And we're talking about drone technologies with point cloud references, so that on a Saturday we can send a drone out in order to travel the exterior of the building and the interior of the building, records a point cloud which is a version of the model, but including orthographic representation as well. So as we are constructing the model, we are again building it digitally, and we are referencing it back off the original model. And once the two reference each other in a correct manner, they can initiate a smart contract in order to initiate payments. Here is a little example of what I'm talking about in terms of drone and point cloud technologies. It's a little bit jerky at the beginning. This is the drone with a camera flying over the site, and the site is up as far as that looks like in situ cast walls, something like that. There's plenty of formwork going in there. Might even be being precast, manufactured and brought to the site. So the information has been taken now and brought into a model, so it's now in a digital format. Masonry model isolated in Navisworks. This can be used as a comparator. We have model checkers available to us which allow us to do this. This is a point cloud survey. And a point cloud survey is a laser survey in which you bounce a laser beam across to a solid object, and it bounces a dot of information back to you. There will be several million dots within this point cloud, but this is easy peasy stuff in terms of where our surveying people are at, resulting in something like this here. So as that building is started to be constructed, as the framework is going up, as the cladding starts, the exterior cladding starts to go onto it, but more importantly, as the interior is constructed as well, this can all be recorded in terms of point cloud survey, which again is digital information and becomes quite interesting when it becomes that. So, smart construction. The use of smart contracts is probably the most promising field because it exploits the main advantage of BIM, which is transparency of information between the parties. If this information is on a blockchain, it's distributed amongst parties so that the principle of neutrality is guaranteed. We could build on this a genuine contractual ecosystem linked to the information shared through the BIM model. Blockchain is in this case a real source of confidence when setting out contracts, given its security, traceability and openness. There are special type of contracts called oracle contracts. For example, a client would retain a contractor to build a building. They would deposit funds into an escrow account, which is managed by a smart contract in a blockchain. This means that the computer will flip the switches instead of the accountant, banker, attorney or surveyor. At certain points of the contract, the Oracle, which is a third-party vetting mechanism, okay, it doesn't need to be a person, but it can be a third-party vetting mechanism, will verify that contracts or the performance agreement has been met, and they would flip the switch, which releases funds to the contractor or back to the client through predetermined decision tree, depending on objective observance or confirmation evidence through evidence-based technologies. This is efficient for the contractor because they don't have to worry about getting paid as long as they meet the conditions of the contract. The client does not need to worry about getting ripped off because they are assured that the conditions of their agreement will be met. The system is efficient because it is high integrity, it is rewarded, and there's little incentive to cheat, which minimises lawyers, accountants, social dysfunction of the public ledger. Here's the core concept. The linking of BIM by making use of its database and the ability to be able to program the BIM database to the blockchain with its security, traceability, to initiate smart contracts, validating virtual value into a confirmation of physical value. That's the hypothesis. Some examples of what I'm talking about here. Here's our planning system. So, an example where blockchain, a smart contract utilising BIM, could revolutionise our industry is its application in the planning process. And design professionals, those of us who have been in the BIM space for a long time, we know the potential of submitting your BIM model for planning assessment as opposed to hard copy drawings or digital PDFs. This exists in Singapore. They are the world's most advanced planning system for the acceptance of building information models as planning applications. Code checking, which can be a little bit of a grey area in terms of planning process, can be enforced with the use of code checking applications. So just literally running through that laborious job that has to be done and checking the areas, making sure that the rooms are of the correct size, that the building is the square metre area that has been represented. We can do that within the space of pressing two buttons with the BIM. And code checking applications can be embedded into the BIM as well. The visualization aspects of the digital model can be used for better decision making by the planners and by the public. And many times have we sent in planning applications to get them sent back because we know that the planners didn't understand quite what we were trying to get to, because the information, the data that we sent in is not representing in the way that we want, that we need it to be represented. The BIM model submitted can be ascribed onto the government planning blockchain with a digital marker, with a timestamp. When planning is granted, a smart contract is activated with the planning permission certificate and the conditions. The planning file is cryptographically secured but open to public scrutiny, and the result is a speedier, more realistic, cost-effective and transparent planning system. Public tender systems, we talked about that, the idea of it's very expensive for people, for contractors to tender, and the idea of, again, having a blockchain in which there's an escrow account set up, in which the tenderer lodges in, say, 10 grand, 50 grand, something like that, and the winner of the tender, the client pays that person back their 10 or 50 grand, but the existing 50 grand that the other 4 or 5 firms that have invested can be withdrawn, or they stay in that escrow account in lieu of the next tender that happens. So something like that is possible to do. Here's one that was mentioned earlier, IP, intellectual property, and the worry that our designers have in terms of intellectual property. And I have put together the double-edged sword of IP and the word that Deirdre taught me last year, causation. I love that word, causation. So, multidisciplinary collaborative BIM can present problems of IP, intellectual property, and causation. Causation being the action of causing something, and investigating the role in the causation of an accident or something like that. And the reason that we had that conversation is that Deirdre came into my class where we had a multidisciplinary project working. We had architects, engineers, construction managers, surveyors, all working collaboratively to design a building. And her worry was, if something goes wrong, who does she get to blame? You know? And she was kind of a bit flummoxed and said, how am I going to decide who was the designer? Who was the designer here? That's great. That was a discovery for us both. But determining authorship of each element of the model is a projected problem coming from the model authors. But it's not just a question of rights over it. It is closely related to civil and criminal liability of a design flaw which might arise on a project. Blockchain can act as a certifier of the activity of each agent of the model. And the importance of this entails determining responsibility towards causation. And here is a blockchain that exists at the moment. It's called ascribe.io. It's currently used for registering ownership of digital art. So you probably all know Banksy, the graffiti artist whose works now sell for 50, 60,000 pounds, but they're all on buildings and walls. How does he ascribe that is his? Well, he can go in and put a description of the art and the time that it was done and log it into Ascribe. It goes onto the blockchain, timestamped as being a signature and the fact that this is his art. Just tweak that a little bit. We can do that for our building information models. We can submit the whole file and have it timestamped and digitally signatured in terms of this is our work, this is my IP. We can even break that down into the constituent elements of the building and the families that we create. The families, for those of you who don't know, are those individual elements that we introduce into the building model. And there is terrible concern in terms of people who create these that once they let them out there that people can use them and they don't get the credit for it. But perhaps more importantly for me is that if that family is changed or tweaked to cause a problem within a building or something like that they have evidence to say that this was my original, somebody has messed around with that, the cause the problem is not with me, you've got to check it out with somebody else. We talked about cooperative housing earlier, and unfortunately we don't have the facility in here to do cooperative housing, and you can correct me if I'm wrong on that. But here's a paper by an architectural student, Malachy, who is using a blockchain to enable co-housing, cooperative housing, and all the advantages that can be derived from that. And again, that paper is well worth having a read. The UK government are taking this really seriously. They have produced a reference paper, distributed ledger technology through the blockchain, and they are actively investigating this in terms of government administration of all the facilities that they provide. ColorCoin is another blockchain which is used for assets, for assigning assets. And again, so the solutions are happening, they're out there. They're not directed towards our industry, which is interesting. So there's a whole area of a gap there in terms of research. Here is a fascinating project. This is over in Germany, and again, it's a blockchain. We are committed now to heading towards nearly zero NZ buildings by the EU Energy Directive. What if we could get to the point where our buildings are not just NZ, but they're NZ positive, where we're actually creating energy? And the problem with that is, not a problem, it's fantastic, but the problem is what do we do with that energy? We can't feed it back into the grid here in Ireland. So what if we could create a microgrid? What if this building has a post outside the building or in a booth or something like that, in which you can go into and you can plug in anything from your mobile phone to your electric car, and you are drawing down energy that is being created by this building. And in order to do that, we need some kind of a payment system, we need some kind of an app which you will run on your phone. You'll go in and swipe it, but it has to identify you and things like that. It's not science fiction, this is happening in Germany as we speak.
Hi, we are BlockCharge, and we will pave the way for the future electrification of mobility in societies around the world. 66% of the world population will live in cities, but already today there are big polluted megacities. The growing number of gas-powered vehicles is destroying our cities. For this reason, several countries are committed to deliver on electric vehicle deployment targets, signaling their long-term commitments to vehicle electrification and improving quality, pampered by and market for an affordable and seamless charging infrastructure. We want to see a fuel electrification infrastructure which is flexible, secure and scalable, enabling sustainable mobility and logistics in large cities. And this is where block charge comes in.
So basically the payment system for that microgrid is organised through a blockchain. Fascinating. Just to round off. So Ralph has illustrated this, but in the BIM world we chart the development or the concepts of BIM using an acronym. So we've gone from 2D to 3D. That is that move from representation to simulation. Our next development was into 4D, 5D, 6D, 7D. What I'm proposing now is that the synergy exists between the reality of BIM models and the reality of blockchain leads me to believe that we have a new BIM dimension, 8D BIM in the blockchain. Thanks very much.